All right, welcome back. In our last explainer, we were left with a real head-scratcher, the dollar bill. How can a simple piece of paper be both a fixed, physical thing and at the same time have a value that can completely disappear depending on where it is? Well, today, we're not just going to talk about that paradox, we are going to roll up our sleeves and build the very architecture that solves it.
So, here's our game plan for today. We'll kick things off by revisiting that core dilemma. Then, we're going to build our solution from the ground up, piece by piece. We'll start with its fundamental particle, the holon. Then we'll layer on the laws of physics that govern it and understand the social contract that lets it cooperate. And finally, the big reveal, the biological blueprint that brings it all together. By the end, you'll see how this takes us from just guessing to actually knowing. Okay, first up, beyond the definition dilemma. Let's just quickly refresh ourselves on this central problem that stumps us and, frankly, stumps most of today's AI. So you remember this puzzle, right? The dollar bill is physically stable. It's always just a bit of paper and ink. You can hold it, you can feel it, but its most important feature, its value, well, that can vanish in a puff of smoke if you take it outside our financial system. How can something be both rock solid and totally flimsy at the same time? It's a contradiction that our usual ways of thinking just can't handle. And this gets right to the heart of two totally different ways of seeing reality. On one side, you have the extensional view, which says a thing is just what it's made of, simple. On the other side, you have the intentional view, which says a thing is defined by what it does, by its relationships. One is fixed, the other is fluid. So the billion-dollar question is, how do you build a system that can understand both of these truths at once?
All right, on to section 2. To crack this paradox, we need a totally new kind of building block. And it turns out it's one nature has been using for, just a few billion years. So let's enter the world of holons.
So, what in the world is a holon? The idea comes from the writer Arthur Koestler, and it's one of those things that seems simple but is incredibly powerful. A holon is something that is a complete, self-contained whole, while at the exact same time, it's also just a single part of a much bigger system. It's a whole and it's a part, simultaneously.
And I love Koestler's metaphor for this. He said a holon is like the Roman god Janus, the one with two faces. One face is always looking inward, at its own components, its own makeup. The other face is looking outward, at the bigger world it belongs to. So it's always aware of both itself and its context.
And this is exactly how the semiotic web is built. These holons nest inside each other like Russian dolls, in a structure we call a holarchy. At the smallest level, you have your personal perspective portal, the PPP. That nests inside the group level, which is a shared semantic system, or SSS. And all of that fits inside the largest level, the Comprehensive Comprehension Cloud, or CCC.
So the really crucial takeaway here is that any holon, no matter which one you pick, always lives in this three-level reality. There's the stuff inside it, the component level. There's the thing itself, the focal level. And there's the bigger system it's part of, the embedding context. This nested, three-layer design is the absolute key to how complex systems create meaning without a central boss calling all the shots.
Okay, so we've got our building blocks, the holons. Now for part 3, what are the rules of the road? What are the laws of physics that tell these holons how to interact? For that, we need to understand the rules of something called semantic spacetime.
Now, don't get hung up on the name. Semantic spacetime isn't about planets and stars. Think of it more like a map, but a map of meaning. The big idea is that knowledge isn't some dusty library full of static facts. It's a living, breathing landscape where meaning isn't in the objects themselves, but emerges from the connections between them.
And in this universe of meaning, it turns out there are only 4 fundamental ways that things can be connected. You can group them together, link them by cause and effect, have them cooperate through promises, or match them based on similarity. That's it. These 4 simple rules are like the fundamental forces of meaning, and they're all you need to build vast, interconnected webs of knowledge.
Moving on to section 4. We have our citizens, the holons, and we have the laws of physics. But how do they form a society? How do they decide to work together? Well, for that, you need a social contract. And this brings us to a network of promises.
Promise theory, an idea from Mark Burgess, is a brilliant model for getting things done without a boss. It's not about top-down commands or orders. Instead, you have autonomous agents who make voluntary, public promises to each other about what they're going to do. It's all about creating reliable systems from the bottom up.
And the whole thing works because of a few core principles. 1, Every agent is its own boss. 2, cooperation is always a choice, it's never forced. And 3, and this is the kicker, trust isn't just assumed, it has to be earned. You trust an agent because you can see that it keeps its promises. This is how you build a massively scalable network based on verifiable trust.
Okay, Section 5. This is the moment where it all clicks. We've just built this seemingly abstract architecture of Hollands and space-time and promises, but what if I told you it isn't abstract at all? What if nature already figured this out billions of years ago? It's time to look at the biological blueprint.
So just think about it for a second. We have a system of nested autonomous agents. Each one has a stable identity but can change its role depending on the context, and they all coordinate using local rules to create this incredible global intelligence. Does that ring a bell?
The answer is inside every single living cell. The entire architecture of the semiotic web is modeled directly on gene regulatory networks. This is the incredibly sophisticated software that runs inside you that tells a cell what to become, when to act, and how to work with trillions of other cells. It's literally the operating system of life. And here's where it gets absolutely mind-blowing. The mapping isn't just a metaphor, it's one-to-one. The way a cell homes in on a stable identity, that's exactly how the system uses semantic DNA. The way a biological network inflates with new connections, that's the system adding new facts. It deflates to prune weak links, it has spiky rapid responses, and it makes steppy gradual changes. This is not an analogy. This is the actual blueprint.
And that brings us to the home stretch. Section 6, from guessing to knowing. We've seen the architecture, we've seen the biological blueprint. Now, let's bring it all back and see how it completely solves that dollar bill dilemma we started with.
So here it is, the solution. This whole system is designed from the ground up to perfectly integrate both realities. The core identity of a concept, its tukum, is fixed and stable. That's the paper and ink of the dollar bill. That's its extensional truth. But its meaning, its role, is determined by its position in the holarchy, and that is completely dynamic. That's its intentional truth. The system doesn't have to choose one. It embraces both.
And this lets us fundamentally rewrite the math of AI. The old formula was basically understanding is approximately equal to a bunch of data. It was a statistical guess, a very sophisticated one, but a guess nonetheless. The new formula is understanding equals an atomic definition interacting with a map of meaning. We are literally replacing that squiggly approximately equal sign with a hard equal sign. The consequences of that one little change are profound. First, that expensive, endless cycle of retraining models, it becomes obsolete. The system just learns by integrating new knowledge. Second, retrieval-augmented generation, or RAG, that popular band-aid to make AIs more accurate, you don't need it. Retrieval is just built in. And finally, explainability isn't a feature you try to bolt on later. It is the architecture. Every answer is fully traceable by design.
Which leaves us with one final thought to chew on. For decades, our intelligent machines have just been incredibly sophisticated guessers. If we are really on the edge of moving from statistical guessing to verifiable knowing, what does that change? What parts of our world, in science, in business, in our daily lives, are we prepared to understand with a clarity we have never had before?